Back here to give you all an update on my ham radio. This is going to be first in several videos. Have it all back together. One of the last videos was putting in the two new final tubes, which were installed. And now you can tell I basically have probe on the input of the driver tube. And this is it all wired up and grounded. This is the TDS 540 that I fixed last year. Going to be using that to do the tests. This is the status. I basically put in the new finals tubes as well as the driver tube. I aligned everything. These are all the alignment trimmers. And I'm getting extremely good power output basically on everything except the 40 meter band. And even on the 40 meter band, if the mode switch is set to CW, continuous wave, I get excellent power output, around 100 watts. But on single sideband, SSB, I get about 10 watts. Now, before anybody makes a comment, says, okay, fine, it's it has to do with the mode. Well, that's the kind of tests we're going to be doing. And basically what it's going to show is that into the RF unit, which is right there, if you see those coaxials, the VCO goes in there, the red is the signal in, and then out of that RF unit, it's heterodyned, and then goes into the driver unit. Well, basically what I'm going to show is that there's no difference between the waveforms going in for CW and for SSB, except the SSB does have a slightly different frequency. That's it. But what is interesting is the output doesn't seem to be very stable from the RF unit, and I think that might be the problem. But we're going to look later on. But I just wanted to update. I recapped all of this. Brand new, if you see that top cap right there, that's a brand new mica, silver mica capacitor. All the ceramics are new. Everything is resoldered, nice and clean, and put in myself. Also the driver unit, which is behind these trimmers. New caps there as well. It did increase the power a little bit on the other bands, but it did not help with the 40 meter at all. So anyway, this is going to be the preliminary beginning of this series of tests to try to ascertain what the problem is on the 40 meter band. This switch here, that's another modification that I put on. Basically what that allows me to do is turn off the filaments for the finals, the PA tubes, and just light up the driver tube. That is very helpful for neutralization, and it's also very helpful for not destroying the finals when you're doing tests. So that's kind of that's a modification that I made myself and placed on the unit. So anyway, we're going to be hooking all this up to the oscilloscope here, and then moving forward eventually come back, and once I re-edit this all together, I'll be putting it on YouTube, and anybody who wants to make some comments, please do, because I really do need help here trying to get pointed in the right direction. I do have some theories, and I'll elaborate on that as I go through the various tests. What we're basically going to do is test the VCO. The waveform show that. We're going to test the input, the driver signal, which is heterodyned with the VCO signal. We're going to show that as well. And then we're going to show the output, the result of the heterodyne out of the RF unit. All that is going to be on this oscilloscope here. I wish I had a bunch of probes, because if I did, I would basically, this is a 4-channel unit, I'd hook all 3 up and show them all together, but I really only have 1 probe, so we kind of operate on a budget here. So I'm going to do this in turn. So okay, I hope you all enjoy the beginning of this series, and it helps someone, and maybe you all can give me some comments. Thanks for watching.